In Asian seafood markets, a single kilogram of this dried product can fetch up to $640. This is bêche de mer, a highly prized luxury delicacy made from processed sea cucumbers, specifically a species known as the sandfish. But before it reaches a display case, the living sandfish experiences a decidedly unglamorous reality. In its natural habitat, this stout, dark gray invertebrate spends its days slowly creeping across the muddy sand of shallow tropical waters. Down in the mud, it relies on a unique biological mechanism called bioturbation. Bioturbation is the active reworking of soils and sediments by living organisms. By continually ingesting dead organic detritus from the ocean floor, the sandfish operates exactly like a biological vacuum cleaner. As the animal digests that detritus, it oxygenates the surrounding sand and excretes waste rich in ammonia and phosphate. These specific chemical byproducts act as a highly effective natural fertilizer for coastal seagrass meadows. An adult sandfish processes dozens of pounds of sediment every year. By constantly recycling limiting nutrients back into the food web, this single species acts as a foundational benthic engine, keeping the entire coastal ecosystem from suffocating. A creature with high protein content, very low lipid levels, and extreme luxury market value creates a dangerous economic combination. Over the course of the last few decades, international demand triggered a highly destructive gold rush-style fishery across the Indo-Pacific. Harvesters systematically stripped shallow reefs and lagoons, causing wild populations to plummet across the animal's massive 70-nation coastal range. The depletion reached a critical threshold, leading to its official classification as an endangered species on the IUCN Red List. The IUCN Red List is the world's most comprehensive inventory of the global conservation status of biological species. The disappearance of the sandfish creates a cascading environmental threat. Without their primary nutrient cycler constantly churning the sand, the seagrass meadows they inhabit face imminent ecological collapse. We face a distinct problem. Global markets will not simply stop trading a multi-million-dollar commodity. To ensure the animal's survival, biologists had to engineer a sustainable production pipeline that exactly mimics nature. This diagram shows how modern aquaculture engineered a biological mirror for the sandfish. It maps the animal's natural transition, from a free-floating larva to a bottom-dwelling adult, directly onto a 5-stage industrial farming pipeline. Stage 1 focuses on broodstock and spawning. Biologists breed millions of larvae inside temperature-controlled, biosecure indoor hatcheries to maximize early survival rates. Inside these vats, the animals pass through 2 highly vulnerable microscopic phases. First is the gastrula, an early embryonic stage, followed by the auricularia, a primary feeding stage where the larvae use tiny cilia to capture phytoplankton. In stage 2, the survivors reach the juvenile, or seed stage. At this point, the animals undergo a biological transition to a benthic phase, meaning they become bottom dwellers, and are carefully transferred to specialized nursery tanks. In the wild, the vast majority of larvae are eaten or die from environmental stress. By isolating and controlling these first 2 stages, scientists bypass that catastrophic mortality, securing a yield of millions of viable juveniles. Stage 3 is the subadult grow-out. Once the juveniles are robust enough, they are relocated into massive 90-acre geometric netting pens situated directly within their native lagoon habitats. From a business perspective, this phase offers a massive economic advantage. Because the sea cucumbers naturally consume the organic detritus already covering the lagoon floor, farmers incur 0 costs for artificial feed or chemical treatments. This diagram shows a cross-section of the ocean pen in action. As the captive subadults ingest dark, dirty sediment, they excrete clean, oxygenated sand, actively releasing essential nutrients back into the water column. Stage 3 flips the script on modern farming. A commercial, high-yield agricultural operation doubles as an active, localized environmental restoration project. After several months, the sandfish reach stage 4, becoming premium, mature adults. Harvesters look for specific biological markers, a weight of up to 600 grams, distinct dark dorsal wrinkles, and a creamy, flat belly. The harvest itself relies on precision. Local divers hand-gather the mature adults one by one. This method ensures 0 bycatch and inflicts 0 physical impact on the surrounding reef or seagrass beds. Finally, in stage 5, the raw biological organism is dehydrated and processed. It is transformed into the bone-dry, premium commodity ready for global export. By strictly controlling the breeding and utilizing natural habitats for growth, this 5-stage blueprint successfully scales a fragile biological life cycle into a repeatable manufacturing process, all without degrading the host environment. Flooding the Asian market with sustainably farmed trepang, another common term for processed sea cucumbers, directly relieves the hunting pressure on wild, endangered sandfish populations. While they grow to market size, the thousands of animals living temporarily in the ocean pens provide coastal lagoons with a massive, subsidized cleanup crew. This highly controlled aquaculture model offers a scalable blueprint. The same techniques can be adapted to save other highly exploited marine invertebrates facing similar global demand. The survival of the sandfish demonstrates that high-value global commerce and ecological preservation can coexist. When industry perfectly replicates the life cycles found in nature, it can feed the economy while actively repairing the ocean.